This question tells us that the following triangles are similar and asks us to find the length of sides x and y in centimeters. X and y, as we can see, are on the triangle on the right that I've colored red for the purposes of this video, just to make it a little bit easier to compare with the triangle on the left that's been colored blue. Let's begin with some of the terms, some of the vocabulary here. What does similar mean? The following triangles are similar. Well, similar in English basically just means that they're kind of alike. But in math, there's a more specific definition, meaning for the word similar, and it means the same shape, but a different size. We can see that these two triangles are the same shape. They're formed the same way. But we can also see that one triangle is larger than the other. So that's what similar means. The question that we need to ask then, if we're going to find out what x and y are, the length of x and y, is how much bigger is one shape than the other? We can see that they're a similar size, but how much bigger is the one than the other? Now, to find that information out, we want to look at two sides that go together on the two different triangles. So, for example, we can look at the height of the two different triangles. On the left side, we can see that we have a height of 3. On the right side, however, we don't have a height given. That's an unknown. We don't know what the height is right now. The height is y. So we don't have two different sides if we use the height to compare. Well, what about the long side of the triangle, also called the hypotenuse? You'll learn more about that in 7th grade, the hypotenuse. But the long side, we don't have here, again, we don't have two different lengths that we can compare. We have 4, a length that's actually given for the blue triangle, but for the red triangle, it's x. So we do not have two sides that we can compare. To have two sides that we can compare, we need to go to the base, as we can see. The base is 2 centimeters for the small triangle, the blue triangle, and 6 centimeters for the larger triangle. So we have two sides that we can compare. Now, from that information, we can see that the ratio of the two triangles is 2 to 6. Or if we simplify those numbers, the ratio is 1 to 3. What that means is that any side on the blue triangle, if we multiply it times 3, we will get the side, we will get the length of the measure on the red triangle. So we can see the ratio is 1 to 3, or times 3 from the blue triangle to the red triangle. Now we know the ratio. It's pretty easy to find the length of the different sides that are missing. For example, x. We want to find x. So the x is the measurement of the long side of the red triangle. So we go to the long side of the short triangle, which is 4 centimeters. 4 centimeters times 3, which is the ratio of 1 to 3, equals 12. So x equals 12. And that's the answer for x. For y, y is the height of the large triangle. We can find y by taking the height of the small triangle, 3, and multiplying times 3, and that gives us 9. 3 times 3 is 9. So the height of the red triangle, the large triangle, is 9. So that's the answer for this particular question, which is x is 12 and y is 9. We found how much bigger the two triangles were by finding two sides that each had a number to go with them. Here, the base for each. That gave us the ratio. And once we knew the ratio, we could find out how much we were multiplying one side by to give us the other. And then we simply went and multiplied sides to be able to get the two missing sides. Once this makes sense to you, go ahead and try the practice problem that is grouped with this question on the homework quiz for this week.